So the next one we're going to do is a rectangle and a square. And remember, a rectangle is a parallelogram with four right angles. And a square is a parallelogram or rectangle with four right angles and four congruent sides. Now, we will construct a rectangle, but then we'll logically go through the process of creating the square. So right away here, I'm going to construct one side of the rectangle. Okay, but you got to remember, now we have to have the right angles. So we have to construct perpendicular lines. So I want to be perpendicular to this line at that point. And now all I do is go through the process of creating my parallelogram. So I'm going to plot a point somewhere on this line, and then I'm going to go parallel line here. Oh, let me undo that. Parallel line here through this point, parallel to this through this point. Then I'm going to go ahead and mark these intersections. Okay, now to make it easier, I'm going to hide these extended lines, right, so that we can construct a much nicer looking rectangle. So here is our rectangle. Now, we know it's a parallelogram, so we already know, right, that the opposite sides are congruent. Okay, so even if I go and measure the opposite sides, you should know that opposite sides are all going to be congruent. Okay, so AB is 4, which means CD is 4, AD is 7.1, so CB is 7.1. Now, we know all of our angle measures are going to be 90 degrees. Okay, so right away when I look, that's a 90-degree angle, that's a 90-degree angle, and as I go around, you'll see that all of these angles are going to be 90 degrees. Okay, so right away when I look here, the next one says to construct these diagonals. Okay, so when I construct these diagonals, the first question, right? So actually, let's go summarize this. So right away, we measured the sides, we measured the angles. Were opposite sides congruent? Yes. Were opposite angles congruent? Yes. Were the adjacent angles congruent or supplementary? Actually, congruent. They were both congruent and supplementary. And were the adjacent sides congruent? No. So we constructed the two diagonals, and we're going to determine, one, are they congruent? Two, do they bisect each other? And then measure the intersection, angle at the intersection. So right away, if I measure the distance from here to here and here to here, what you notice right away is they tell us AC is 8.1 and BD, right, is 8.1. So in this case, we can say that the diagonals are congruent. So we can say the diagonals are congruent. Then now let's plot that point at the intersection. Right away, because we know it's a rectangle, you already know that the diagonals are going to bisect each other because it's a form of a parallelogram. So even when I measure this, 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 and this, you will see clearly that the diagonals do bisect each other. Okay? Not only do they bisect each other, but if the diagonals are congruent and they bisect each other, all four of these are going to be congruent, right? Which is something that we're going to elaborate on here. Sometimes, like, students have trouble memorizing all the different properties, and I tell them to think about this logically. If we draw this rectangle out, oh, this is horrible. Sorry. Okay, right away when I draw these diagonals in, first off, we said the diagonals are congruent. They do bisect each other, right? And if you think about it, if the measures of the diagonals are congruent and they're bisected, all four of these pieces end up being congruent. And if you look at it, what is the best name we can give to each of these triangles that are created, right? Each triangle ends up being isosceles. And sometimes logically using that concept helps out tremendously. Now, do the diagonals end up being perpendicular to each other? Well, all we have to do is measure one of the angles, and right away that angle ends up being obtuse. Therefore, the diagonals are not perpendicular to each other. Okay, so next, let's go ahead and measure, say, these angles here to see if the diagonals bisect opposite angles. And right away when you look, right, the answer to that question is no. All right, so when we look at it, are the diagonals perpendicular? No, right? And do they bisect both pairs of opposite angles? No. Okay, so right away here, the only thing we can say or add to the theorem list here is the fact that the diagonals are congruent to each other. So again, I can't say this enough. Because a rectangle is a parallelogram, you know right away that it has all the properties of a parallelogram in addition to the property of a rectangle here, which is the diagonals are congruent. Okay, so now let's think about this logically. Is a square a parallelogram? And the answer to that is yes. So what properties does it have? Right? We know it has four congruent sides. We know that opposite sides are congruent. Then we know opposite angles are congruent and supplementary. Okay. Now, is it a rectangle? Yes. Therefore, we know, we know diagonals bisect each other. And in a rectangle, the diagonals are congruent. Is a square a rhombus? Yes, it is. Therefore, we know the diagonals, in addition to this, bisect opposite angles. All right. And we could also say that the diagonals are perpendicular. So what happens is all the properties of a parallelogram exist in a square. All the properties, additional properties of a rectangle exist in this, and every property of a rhombus, right, exists in a square. So all of these properties hold true in a square. Okay, so right away here, when we look at the first example, find the length of the diagonals of the rectangle if FD, so this segment here, is 2y plus 4, and GE, right, ends up being 6y minus 5. Well, we know the diagonals are congruent, so we're going to take their measures, 2y plus 4, set them equal to each other, so 6y minus 5. So 4y is equal to, negative 4y is equal to negative 9. So y is equal to 9 over 4, which is 2.25. So to find the length of these diagonals now, once I have y, FD we know is equal to GE. So I'm just going to plug y into one of these. So 2 times 2.25 plus 4 will give me 4.5 plus 4. So each diagonal has a length of 8.5 units long. So in this rectangle, right away they tell you angle DEA. So DEA is 35 degrees. So that's the given angle measure. So they want you to find all of these other angles. Well, think about it. These are vertical, so that's 35. Now, these are supplementary because it's a linear pair. So 180 minus 35 is 145, which makes this 145. So if you remember what I said a minute ago, the diagonals are congruent. Therefore, this piece is congruent to this piece, is congruent to this piece, is congruent to this piece, creating 4 isosceles triangles. Now, 2 of them are congruent to each other, and the other 2 are congruent to each other. So what I'm going to do to find the rest of these angles, if I take 180, I subtract 135, we know I'm going to get 145, and if I divide that by 2, this angle is 72.5 degrees, this angle is 72.5 degrees. Now right away, these are alternate interior angles, so that's 72.5, which makes this 72.5. I could do the same process also. Now, I can go about finding these angles one of 2 ways. One way I can find these angles, right, is what do these 2 angles have to add up to? Well, aren't these right angles? So 90 minus 72.5, that would be 17.5 degrees. Now again, even if I do 180 minus 145, right, that would give me 35 divided by 2, 17.5. So either way you do this, all 4 of these angles are 17.5 degrees. So AED, right, we know is 35 degrees because that was given. EAB was 17.5 degrees. ABE, 17.5 degrees. EBC is 72.5 degrees. E to C to D is 17.5 degrees. EDC, 17.5 degrees. EDA is 72.5 degrees. And BCE, 72.5 degrees. Okay, so right away, using the isosceles triangles makes it easier to understand this one. Okay, the next one, they tell you ABCD is a square. Find the measures of these angles. Well, right away, if you think about it, we know this is a right angle, this is a right angle. Now, this is a right angle, but because a square is a rhombus, right? We know the diagonals bisect opposite angles. So if we take 90 and we divide it by 2, we know we're going to get this angle is 45, this angle is 45, 45, and 45. So we're using the idea that a square is a parallelogram, it's a rectangle, and it's a rhombus. And right away, when I look at that, all 4 of those angles are going to be 45 degrees because the diagonals in a rhombus bisect opposite angles. So angle ABC we know is 90 degrees. Angle ADC is 90 degrees. Angle DAC, 45 degrees. And ACB is 45 degrees. All right. So again, the explanation would be the fact that a square is a rhombus and a rectangle. Diagonals bisect the opposite angles in a rhombus. And if the angles are 90 degrees, all right, each of them are 45. In the next one, they tell you AE is 2x, and they tell you DB is 24. Okay, well, think about it. In a square, right, diagonals bisect each other, so these pieces are both 2x. And if this diagonal is 24, each of these pieces will be 12. Well, remember, the diagonals in a square are congruent, and they bisect each other, so all 4 of these pieces are 12. So the easiest way to find x is just to say 2x equals 12, so x equals 6. Well, now, again, all of these angles, angle ACB, you know they're all 45 degrees because it goes to talk about the problem up above. In a square, it will always have these measures. So ACB, right away is 45 degrees. AED, we know it's a rhombus and the diagonals are perpendicular, so this is 90 degrees. BEC is 90 degrees, and BCA, right, is going to be 45 degrees. Okay, go ahead and do me a favor and